Let's do this guy. We're going to do it by slices, which we're more familiar with, and in this case is easier. And then we'll do it by shells. Okay, you can do any volume either way. Sometimes, as you'll see, one is better than the other, one of which is more superior. Okay, so let's quickly draw it, right? Let's draw this guy. Square root of x, right? So you're getting that half of that sideways parabola, like so. Okay. We're from 0 to 4. Now we're going around the x-axis, like so. Okay, so first let's do it by slices because we're more familiar with that. If we're doing it by slices, which way do the areas go? Do they go up and down or do they go left and right? If I want slices out of this thing, I think you want to take a shape like this, don't you? You want to take an area like that, right? Once you take that area and you rotate it, there's your annular disk. It just so happens that your inside radius, in this case, will be 0. Okay, so let's actually fill. Okay. So how am I going to do this line in here? Okay, by slices. The volume is equal to, okay, now the limit will be, this time it'll be x approaching 0. See that? It's getting thin. See how important the diagram is so you get all these pieces right? Delta x is approaching 0. What are my values? I'm going to go from x equals 0 to 4 because they're the boundaries I've had provided to me. Okay. Then you've got, okay, here comes the area of the annular disk, right? The volume, I should say. Big radius squared, little radius squared. What is this radius? What's it equal to in this case?
Y.
It's equal to, like, it's the vertical distance. It's y, right? But because of the axis that I am going to be integrating across in a second, right? I don't want this in terms of y. I want it in terms of x, right? So instead, I should put in here square root of x. That's the y, but it's squared, isn't it? It's big radius squared. Minus the little radius squared, which just happens to be 0, and delta x. There you go. There's the width of each one. Okay? Turn this guy into an integral. There we go. Pi is out the front, 0 to 4. It's just that. That's all. Okay, let's quickly do it. Pi there. What do we get? X squared on 2 from 0 to 4. The naught's going to disappear. That looks like 16 on 2. So it's sounding like 8 pi cubic units. So far, so good? Okay, now, how do we do this by shells? Okay, draw yourself a new diagram. It doesn't have to be huge or beautiful, but you have to be able to read information off it. Okay. The graph's going to be the same, and the boundary is going to be the same. 4. Still rotating around here. Okay. But this time, I'm not going to be choosing these kinds of chunks. I'm going to be choosing a chunk like this. See, I'm parallel to the axis of rotation now. Okay. So when you rotate this around, that's what gives you this, or here's an example. Okay, there you go. So there's one of my shells. Okay. So start off, volume is equal to. Okay. We start by saying limit now. The width that I'm going to reduce and take the limit to is it's a vertical width, right? So that's why this is going to be delta y, and it's going to approach 0. Okay. Now, because I'm talking in terms of y's now, right? I'm actually not interested in x boundaries anymore. I'm interested in y boundaries. Okay. So I'm thinking this way. Can you see when I add up all of these, right? There's one, there's the next one, and the next one, and the next one, and all these, they're all going to add up, okay? So what are my new boundaries? They're not 0 to 4. It'll be from 0 here up to, this is going to be 2, isn't it? Because it's the square root of 4, okay? So there you go. That's fine, okay? Now I'm up to this stage, okay? 2 pi. Now, what's the radius and what's the height? Be careful, okay? Here's the radius here, okay, radius. There's the cylindrical shell. Now, I'm doing everything in terms of y's, okay? So how shall I express that distance? It's just y, isn't it? That's all. That distance there is y, okay? So the radius, r, is y. When I want the height, it's this guy here. That's the height of my cylindrical shell. Now this is a bit harder. You have to be careful, okay? Take some values and be careful over here. For instance, if I take that value up there, okay? What for this value, right? What will the height of the cylindrical shell be? And the answer is it'll be 4, right? That distance there. Is that okay? Really? Be careful. See, this distance is 4, but the cylindrical shell that I get from up there is actually that guy. It's going to be, the shell that I'm after, the height will be 0, okay? So in fact, the real height that I'm after here is not 4. 4 is what this distance is all the way along. It's actually 4 minus whatever x value you're having. Okay, 4 minus x. But I don't want x, right? I want this in terms of y's. That's what I'm going to integrate with respect to in a second, right? So how do I write this in terms of y's? Well, yeah, x is going to be y squared, isn't it? Okay, see that, right? So now I say that's 4 minus y squared. Aha, that's the height of my cylindrical shell. See how careful you have to be. 4 minus y squared. There you go. Radius, height. I need one more piece to make it a volume. Delta y. Delta y. The thickness of the shell. Okay, great. Let's turn it into an integral. What's going to come out? The 2 pi will come out the front. I'm going from 0 to 2. What's this going to become? 4y minus y cubed? Yeah? People are looking at me funny. Have I done something wrong? Okay? Okay, I think I'm okay. With respect to y. Okay? Now I can integrate. 2 pi is still out the front. This will become 2y squared. This will become y to the 4 on 4 from 0 to 2. Okay? I'm going to crunch the numbers on this one. I'm going to get 2 times 2 squared, which is 8. Here I'm going to get 16. Sorry, yeah, 2 to the 4 is 16 on 4, which is 4. The 0 one's just going, well, I should put that in, shouldn't I? There you go. Okay. 2 pi times 4 is the same volume that we got before, as you'd expect. Okay? So, be careful. You remember I said before, you've got to have the diagram, right? It's very, very important so you can get pieces like this.